All right, so ladies and gentlemen, we're going to start talking about accelerated motion, and when we start, initially we're going to start about talking about accelerated motion. That's along the horizontal. We'll have a separate video lecture for accelerated motion vertically. All right, so regardless of whether you're going in the X direction or the Y, these two concepts of uniform and non-uniform motion are going to be the same. So uniform motion is motion along a straight line with an unchanging velocity. So when you are in uniform motion and you close your eyes, you feel as if you're standing still. So uniform motion feels smooth, and the reason it feels smooth is because you are moving at constant velocity. Okay? Non-uniform motion is motion in which velocity changes. So the velocity could change in speed, go faster or slower, or direction. So in non-uniform motion, you feel a push or a pull. So things like slamming on car brakes, that is non-uniform motion. Taking off in an airplane. That's non-uniform. So in both of those examples, you feel something happening. Okay, so acceleration is defined as the rate at which an object's velocity changes. So anytime an object speeds up or slows down or changes direction, it's accelerating. So when an object's acceleration changes at a constant rate, it's called constant acceleration. So when an object is experiencing constant acceleration, the object will continue to speed up, going faster and faster and faster and faster, or it's going to slow down. So it's going to keep going slower and slower and slower and slower. Okay, and then the unit of acceleration is meters per second squared. All right, constant acceleration equation. So let's see. The most simplest is VF equals VI plus A times T. We have XF equals XI plus VI T plus 1/2 A, whoops, that didn't write, T squared. And then finally, we have VF squared equals VI squared plus 2AX. So, what do all these things mean? All right, so let's go to the meanings. VF is the final velocity. So the velocity that ends the motion. VI equals the initial velocity, so the starting velocity. A is acceleration. And then T is the symbol for time. Okay. XF is the final position. And then XI is the initial position. And in about 95% of the cases, I have a problem with that. XI is going to equal 0. So unless the problem tells you specifically that it's starting at the 10-meter mark, you can assume that the XI is 0. Okay, velocity time graphs. We're not going to spend a lot of time on that in this section. We'll go over more in class. If you have a positive slope, you've got positive acceleration. If your slope is equal to 0, you have 0 acceleration, but please realize that the object is still moving. It's just not accelerating. And then negative acceleration means that the object is going to be slowing down, so it has a negative slope. And again, we'll do more with velocity time graphs in class. All right, so here we go. We need to calculate the acceleration of the objects along each segment, A, B, B, C, E, F, and G, H. So let's start with AB. So for this section right here, AB, our initial velocity is 0. Our final velocity is 20. And the time that it takes to get from 0 to 20 is 2. And we are looking for acceleration. So we're going to do VF equals VI plus AT. So 20 equals 0 plus A times 2. Divide both sides by 2. And we get that A is 10 meters per second squared. All right. So next we're going to do segment BC. So for segment BC, our initial velocity is 20. Our final velocity is 20. The time that it takes to get that change is going to be 2 seconds. And we're looking for acceleration. So VF equals VI plus AT. So 20 equals 20 plus 2A. Subtract 20 from both sides. And we're going to get 0 equals 2A. So A is equal to 0 meter per second squared. Okay. So now we're doing segment CD. Alright, so in segment CD, our initial velocity is 20. Our final velocity is 40. And then the time interval is 1 second. T equals 1 second. A is what we're looking for. Alright, so VF equals VI plus AT. So VF is 40. VI is 20 plus 1T. Subtract 20 from both sides. That goes away. And then we have 20 equals 1T. So that means T is equal. I don't want to solve for T. Ding dong. I want to solve for A. So that's 1A. 1A. A is 20 meters per second squared. Alrighty. Now we're not going to find DE because I think you can realize that the acceleration there is 0. So now we're going to EF. Okay. So for EF, our VI is 40. Our VF is 20. Our time is from 8 to 10, so 2 seconds. And we're looking for acceleration. So VF equals VI plus AT. So 20 equals 40 plus A times 2. I'm going to subtract 40 from both sides. That goes away. And we get negative 20 equals 2A. Divide both sides by 2. And we get A is equal to 10 meters per second squared. Negative 10. Gotta have that negative. Don't drop your negatives. Alright, because that negative means that it's slowing down. Excellent. Alright, last segment. We have to do G to H. So on segment G to H, we are starting at 20. So VI is 20. VF, it looks like, is 30. The time is 1 second. And we're looking for A. So VF equals VI plus AT. 30 equals 10 plus A times 1. Subtract 10 from both sides. And we get 20 equals 1A. So A is equal to 20 meters per second squared. There we go. So now we've calculated acceleration based on a velocity time graph. Okay, so here are some sample problems. These are similar to the ones you'll find on your problem set. A car with an initial speed of 6.5 meters per second accelerates at a uniform rate of 0.92 meters per second squared for 3.6 seconds. Find the displacement or the final position of the car during this time. So let's see what we know. We know that VI is 6.5 meters per second. We know that A is 0.92 meters per second squared. We know that the time is 3.6 seconds. And we are asked to find the displacement. So it wants to know the final position is what we're looking for. So going back to those equations that we had, we want to go as direct as we can to the quantity we're solving for. Okay, so we want to do XF equals XI plus VIT plus 1/2 AT squared. Now remember that in 95% of the cases, XI is equal to 0, so that's going to go away. So now we know VI, we know T, we know A, and we know T. We can find XF without having to go through any other equations. So XF equals 6.5 times 3.6 plus 1/2 0.92 times 3.6 squared. All right, so let's multiply 6.5 times 3.6. XF equals 23.4 plus 3.6 squared, enter, times 0.92, enter, divided by 2 is 5.96. So XF is 5.96 plus 23.4, 29.36 meters. Okay, so as you work through these types of problems, you'll find that picking out the equation to use will become easier and easier the more you practice them. Okay, I kind of like this blue. It's kind of nice. All right, an automobile with an initial speed of 4.3 meters per second accelerates uniformly at a rate of 3 meters per second squared. Find the displacement after 5 seconds. All right, so this is very similar to the one that we just did, because we're given that VI is 4.3. We know the acceleration, 3 meters per second squared. We know that the time is 5 seconds. And we're asked to find the final displacement, XF. All right, so we're going to use the exact same equation that we used in number 1. XF equals XI plus VIT plus 1/2 AT squared. So they didn't give us an initial position, so this term goes away. We can assume it's 0. So XF equals 4.3 times 3 plus 1/2. Oh, that's not a 3 there, that's a 5. 4.3 times 5 plus 1/2 3 times 5 squared. So XF 4.3 times 5 is 21.5 plus 5 squared is 25 times 3 divided by 2, 37.5. So that's going to equal 59 meters. All right. For part B, they want us to find the final velocity. So here we're solving for VF. So the easiest equation to use is going to be VF equals VI plus AT. So VF equals 4.3 plus 3 times 5. So VF equals 4.3 plus 15, which is equal to 19.3 meters per second. Okay, and then our last problem that we're going to do together says a car starts from rest and travels for 5 seconds with a constant acceleration of negative 1.5 meters per second squared. What is the car's displacement? So if the car is starting from rest, our VI is 0. The time is 5 seconds. And the acceleration is negative 1.5 meters per second squared. And we want to know what's the final position of this car after 5 seconds. So again, we're going to do XF equals XI plus VIT plus 1/2 AT squared. There we go. XI is 0 again, so crossing it out. So XF equals 0 times 5 plus 1/2 negative 1.5 times t squared, which is going to be 5 squared. All right, so this term right here goes away because we have 0 times something, so that's not going to help us. So XF equals 5 squared is 25 times 1.5 divided by 2. It's going to give us negative 18.75 meters. So this negative just means that it's to the left of the origin. Or another way to say it would be west. All right, last part, what is the final velocity of the car? So now we're looking for VF. So VF equals VI plus AT. VF equals 0 plus negative 1.5 times 5. So VF equals negative, I believe that's 7.5 meters per second. And again, that negative is because of the direction. All right, well, we'll practice some more in class. Make sure you have your problem sets with you. All right, bye-bye.